Good afternoon. Welcome to the platform of Odont Academy of Learning. I'm Dr. Nikita Manur, an MDS in Endodontics. Today I will be presenting the topic Instruments in Endodontics. I'll be covering this topic under the following headings: Introduction, Classification of Instruments, Standardization of Instruments, the make of endodontic instruments, what are the terms that we use with endodontic instruments, hand instruments, rotary devices, clinical considerations, and references. Coming to the introduction, instruments play a very important role in the success of root canal treatment. Therefore, it is very important to understand how the instruments work. We have a general guideline for root canal preparation, but every canal is different, and there is a lot of variation in the canal anatomy in each case that we see. Therefore, root canal preparation presents unique challenges in different ways. We have a variety of instruments available in the market for this purpose. Coming to the classification, according to Grossman, he classified instruments into 4 types: exploring instruments, debriding instruments, cleaning and shaping instruments, and obturating instruments. So exploring instruments are nothing but our endodontic explorers and the smooth broaches. They are used to locate the canal orifice and determine whether the canal is patent enough or not. Coming to the debriding instruments, these are used to remove the pulp from the canal, and the best example for this is a barbed broach. Coming to the cleaning and shaping instruments, cleaning and shaping is done basically by files and reamers, and it is in order to increase the size of the canal and to make sure that we are cleaning and shaping both laterally and apically. Coming to the obturating instruments, these are used in order to place the gutta percha inside the canal. So we have spreaders, pluggers, and lentulo spirals. Now, what is the classification according to ISO FEI? We have group 1, that is hand use only. For example, K files and H files. In group 2, we have engine driven latch type, that is Gates glidden drill and PEESO reamers. Group 3, we have engine driven NiTi rotary instruments, for example, Profile and ProTaper. In group 4, we have engine driven 3D adjusting instruments, for example, self-adjusting file system. And in group 5, we have engine driven reciprocating instruments, which are example is Wave 1. Group 6 is sonic and ultrasonic instruments. Coming to the clinical classification, we have instruments used for diagnosis. Under that, we have endodontic explorers, tooth sleuth, dental transilluminator, and pulp vitality tester. Coming to instruments used for access opening, we have diamond rose head burrs, tapered burrs, carbide burrs, safe long end burrs, and endo Z burr. So if you can look at the picture, you will understand how the burr anatomy is and what it is used for. So commonly what we use for access opening is the endo access burr, which has a round end and a long shank. And the second one that we use commonly is endo Z burr, that is for lateral finishing of the access opening to make the lateral walls more smooth. Coming to instruments used for canal preparation, instruments used to remove pulp tissue, we have barbed broaches and endodontic excavator. If you can see this picture here, in this picture, you can see that these barbs which are present on the broach, they are the ones which cause the pulp tissue to get stuck to this. These barbs will cause dislodgement of the pulp tissue from the canal. Now, coming to instruments used for canal preparation, we have reamers and we have files. You can see the cross section. The cross section of the files and the reamers, the difference is the reamers, the flutes are more apart, whereas in the files, the flutes are more tightly bound to each other. Coming to instruments used for root canal obturation, we have lentulo spirals. Lentulo spirals are used for placing the sealer into the canal and coating the canal. Then we have spreaders, we have pluggers, we have condensers, heat carriers, and thermomechanical compactors. Now, how do we standardize endodontic instruments? Before 1958, endodontic instruments were manufactured without any established criteria. However, now we have a standard system of naming the instruments and color coding the instruments. So Ingles' original recommendation said that the cutting blade should be 16 mm in length, as you can see in this picture, and 2% taper was advocated, which is the standard taper even now for all the hand instruments that we use. The diameter of the instrument at the tip is determined by size in hundredths of a millimeter, and D2, that is the distance between D1 and D2, is uniformly 0.32 mm greater than D1. And the standard length of all the files that we use comes in three types: 21 mm, 25 mm, and 31 mm. Also, two modifications were made to Ingles' original proposal, in that the additional measurement at D3, that is 3 mm from the tip, that was measured, and specifications for shape of the tip is that 75 degrees plus or minus 15 degrees was mentioned as the specification for the shape of the tip. As you can see in this picture, this is the angle that we're talking about. Okay, the angle that is formed at the tip here with the shank on either side. This is 75 plus or minus 15 degrees. And this is the length, 16 mm from D1 to D2. Coming to the color coding, so with the exception of pink, gray, and purple, all the other colors are repeated in every 6 instruments. So this was introduced later, 6, 8, and 10 number. It started from 15 initially. So 15 is white, 20 is yellow, 25 is red, 30 is blue, 35 is green, and 40 is black. And the same thing repeats again from 45 to 80, and again from 90 to 140. 6 is pink color, 8 is gray, and 10 is purple. So pink, gray, purple is your initial files, the small files that we use, especially for a calcified canal. And then your color coding starts from white, that is 15, 20, so on and so forth. So this is the standard color coding for endodontic instruments, which is followed till date. As you can see here in the picture, this is the geometric shape coding. Depending on more or less the cross section of the file, we have a K reamer, which is triangular shape, a K file, square shape, an H file, which is round, a RASP, which is more or less a star shape, and then we have a pulp extraction, which is again a star shape, a canal filler. So this is how we recognize the file based on the geometric shape coding. Coming to the make of endodontic instruments, that is into the metallurgy, we have carbon steel instruments, we have stainless steel instruments, and we have NITA instruments. Today, the use of NITA instruments has increased exponentially because they have shown that they have two properties: superelasticity and shape memory, which has helped in endodontics in creating the canal, in making the space for the obturation, in cleaning and shaping. As these, they don't break that easily, they have better adaptability to the canal anatomy. So NITA instruments are now used much more as compared to before. Carbon steel contains less than 2.1% of carbon. Stainless steel are more corrosion resistant, and NITI, they contain 55% nickel and 45% titanium. Now, carbon steel. What is the advantage of carbon steel is that it is more harder than stainless steel instruments. The only example of carbon steel that we use is barbed broach, which is used to extirpate the pulp from the canal. It is prone to corrosion, so it cannot be autoclaved, and it is also prone to rust. Since carbon steel contains more amount of carbon, it rusts very easily. Therefore, storage of this instrument and cleaning it and autoclaving becomes difficult, because anything that we do exposes it to water, and that leads to rust. Coming to stainless steel instruments, example, we have a K file. They are highly corrosion resistant, but they are stiff in nature and they are prone to fracture and distortion. So all the hand instruments that we use, you always have this one fear that it will break inside the canal, because it's not as flexible. It's not very flexible. It doesn't adapt to the canal anatomy very easily. Therefore, all the hand instruments that we use, which are made of stainless steel, have to be used with a lot of care inside the canal. Coming to NITI instruments, the advantage is, as I mentioned before, shape memory, superelasticity, low modulus of elasticity. It is corrosion resistant. It is much softer than steel. It has good resilience, and it is extremely biocompatible. Shape memory is that it retains the shape that it has kept before. That is, let's say the canal is curved, it goes into the canal and takes the shape of that curved canal. It comes back out as a straight file only. So it retains the original shape. And super elasticity is that it is self-explanatory, this term is that it's a very elastic file. It doesn't deform easily, it doesn't break easily, it can bend very easily, and it can come back to its original shape. It rebounds to its original shape with a lot of ease. But the cutting efficiency definitely is compromised here because it's not as stiff and it does not show sign of fatigue before fracture. So one problem with the NITI files is that you cannot tell when it's going to fracture very easily. The flutes don't unwind as such. You will not see very obvious signs of wear, but that's why it's advised to, preferably NITI files are supposed to be used once or twice and then you have to discard them. Poor resistance to fracture as compared to stainless steel, definitely. Resistance to fracture is much lesser as compared to stainless steel. The make of endodontic instruments. So a hand-operated instrument reamer or file begins as a round wire, which is then modified to form a tapered instrument with cutting edges. They're manufactured by two techniques. One is machining and the other one is grinding and twisting. So in machining, the instrument is directly machined on the lathe, for example, an H file and NITI instruments. But grinding and twisting is done when raw wire is ground into tapered geometric blanks. For example, when we have a square shape, triangular, or a rhomboid shape, and this is done with a K file or a K reamer. And blanks are twisted counterclockwise to produce cutting edges. So this grinding and twisting, what is done is mostly for K files and reamers. Now, when you have to take into account the components of a file, we have to take into account taper, then the core, the flute, the cutting edge, the land, the helix angle, the pitch, the rake angle, the cutting angle, and tip design. Now, what is taper? Taper is nothing but it is the amount of file diameter that increases every millimeter along the working surface of the tip, from the tip towards the file handle. So this is the file handle. From the tip towards the file handle, in every millimeter, what is the amount of increase that is considered as taper? So the standard what was mentioned was from D1 to D16, or this is also known as D2, 0.32 mm increase in diameter from the tip. This is 2% taper. In a 6% taper, what happens is from D1 to D16, there is a consecutive increase of 0.96 mm increase in diameter. This is what we call as 6% taper. Now, these are the instruments with the following tapers. In profile, we have a 2% taper, 4% and 6%. Hero 642, again 2%, 4%, 6%. K3, 2%, 4%, 6%. Flexmaster, 2%, 4%, 6%. And the introductory file has 11%. That is the orifice shaper. Race, 2%, 4%, 6%, 8%, and 10%. Subsequently, we have Quantec SC, M2, GT file, Lightspeed, and Pro Taper. All the tapers here are mentioned. You can go through this. Now, coming to the core, it is the cylindrical central part of the file. Okay, as you can see in this picture, this is known as the core. The central part of the file, which has its border, is outlined by the depth of the flute. So this is what is called as the core. You can have a look at this picture. I think it is quite self-explanatory. Coming to the flute. Flute is basically nothing but this groove on the surface which collects the soft tissue debris which is removed from the canal wall. So when you introduce a file into the canal and when you're taking it out, right, the area where you see the debris has been collected, that area is nothing but the flute. The effectiveness of the flute depends on the depth, width, configuration, and surface finish. So these two here are the cutting edges, okay? And this area in between, the flat area, is the flute, which extends from one cutting edge to another cutting edge in between. What is the cutting edge? Cutting edge is the surface with the greatest diameter that follows the groove as it rotates. It forms the leading edge or the blade of the file. This is nothing but the blade of the file. You can see this, the sharp elevation here on the file. All of these are cutting edges. The sharp area here. Coming to land or marginal width, the surface that projects actually from the central axis as far as the cutting edge between the flutes. It prevents the screwing in effect of the file basically, and it supports the cutting edge. It limits the depth of cut. Here you can see this area is the land in this picture. Here you have the cutting edges here. This part in between is nothing but the land. And it supports the cutting edge. It reduces the propagation of micro cracks because it helps to dissipate the forces equally, and it maintains the file in the center of the root canal. So to keep the file more centered and not towards one particular side, and to make sure that even amount of dentine and soft debris is removed from the canal on an equal amount, we need to make sure that the land is placed properly, as in the file is designed in such a way that the land is placed properly on the file. Coming to the helix angle, the angle formed by the cutting edge with the long axis of the file is known as the helix angle. You can see the cutting edge here. These two are cutting edge with the long axis, and in the center, this is the long axis of the file. So the angle that is formed with the straight long axis with the cutting edge is known as the helix angle. It helps in the removal of debris collected in the flute from the file. So basically, when we talk about helix angle, this is the center of the file, this is the long axis, and this is the cutting edge. So there is an angle formed here. If this angle is more positive, then you have better cutting efficiency of a file. Now pitch. The pitch of the file is the distance between a point on the leading edge and the corresponding point on the adjacent leading edge. You can see here in this picture, this distance between 2 points on the leading edge. Leading edge is nothing but your cutting edge. So 2 points here, and this is the pitch. Or it is the distance between corresponding points within which the pattern is not repeated. Variable pitch is nothing but the number of flutes per unit length. The number of flutes per unit length can change with every file. That's why the pitch varies. Rake angle. The angle formed by the leading edge and the radius of the file when the file is sectioned perpendicular to its long axis. So here you can see this is the neutral rake angle. Ahead of that is the positive rake angle, and behind is the negative rake angle. So a file which has more positive rake angle has better cutting efficiency, and a file which has negative rake angle has poor cutting efficiency. Cutting angle. The cutting angle or the effective rake angle is a better indication of the cutting ability of a file. It is obtained by measuring the angle formed by the cutting edge and the radius when the file is sectioned perpendicular to its cutting edge. Now coming to the design, the tip design, it can affect file control, efficiency, and outcome in the shaping of root canal systems. The tip of the original K file, it resembles a pyramid, as you can see in this picture. Instrument tips have been described as cutting, non-cutting, partially cutting, although there is no clear distinction among the three types. Now coming to tip design, Powell et al. Pointed that when the tip angle is reduced, the file stays centered within the original canal and cuts all the circumferences more evenly. So if you can see in this picture, the tip of the file is almost in the center. It is definitely much towards the center. Therefore, what happens is when this angle is in the center, the file stays more towards the center of the canal and does not deviate from its path. The modified file tip has been marketed such as Flex R file. This is for more amount of flexibility. The terms used: elastic limit. So the maximum stress that can be applied to a metal without producing permanent deformation is known as elastic limit. And the application of external forces causes internal stresses that cause deformation. The stresses are not too much, the metal will return to its original dimension on the removal of the stress. So this characteristic we see very commonly with nitrile tiles. Now, what is stress? It's nothing but the amount of force that is acting on a particular material, right? And it is defined as force by area. So force by area, also known as Newton per meter square. It is a quotient of force divided by the area. So how much force you are applying on a particular area is nothing but the stress. Strain is the amount of deformation that the metal is undergoing. It is the change in length divided by original length, and strain doesn't have any units. Elastic deformation is nothing but the reversible deformation that does not exceed the elastic limit. So this is undeformed. Here we have deformation and it comes back to undeformed. This is the elastic deformation. Shape memory. Property of an alloy to return to its original shape when heated. So as you can see in this picture, this is the actual shape. It's been heated and then it has to come back to its original shape. So this is called a shape memory. Hand operated instruments, we have barb broaches, rasps, K files, K reamers, and H files. Coming to barb broaches, they are short handled instruments used for pulp extirpation, as I mentioned. They also help to remove loosened debris, necrotic canals, and remove paper points or cotton pellets just stuck inside the canal. They are manufactured by notching a round tapered wire with a blade to form sharp projecting barbs that cut or snag tissue. Broaches and rasps show some significant differences in taper and barb size. So this is a broach and this is a rasp. Okay. In broach, it has lesser taper of 0.007 and rasp has more taper of 0.015. The barb height is much higher in the broach than the rasp. As you can see, this is the height of the barb. Here they are placed much closer together in the rasp. Now, smooth broaches are also known as pathfinders. They are basically used to check for the patency of the canal and to locate the orifice of the canal. And it is the newly released Pathfinder CS is made of carbon steel, is less likely to collapse when forced down in a fine canal. And coming to K files and reamers. So Kerr company designed the K file and reamer. The files that enlarge the canals with reciprocal insertion and withdrawal motion. Mostly we use the K file in watch winding motion, that is quarter turn clockwise and then anti-clockwise. K files blade angle makes them best suited for cutting dentine in the filing motion. Reamers cut and enlarge canals with rotational motions, whereas K reamers have a rake angle which makes them most efficient in rotary motion, hence reaming motion is preferred. You can see in this picture, this is a K file and this is a K reamer. The flutes are more tightly wound in a K file, whereas they're more far apart in the K style reamer. This is the K reamer cross section and the angulation, that is 60 degrees. In a K file, it's square shape and we have 90-degree angle here. So this is the cross section of the file. This is a K reamer and this is a K file. Now, a K-flex file was introduced because we need more flexibility inside the canal in order to negotiate it. The cross-section of the K-flex is a rhombus or a diamond shaped, and the new cross-section presents significant changes in instrument flexibility and cutting characteristics. Now, coming to a flex R file, it is made by removing the sharp cutting edge from the tip of the instrument, and the tip is more rounded. The flutes are sharper and it has a less negative rake angle than a traditional twisted K file. Coming to the modified K instruments, we have a C file which was specifically used for penetration of calcified canals. These are made of specially treated stainless steel for stiffness and strength, and the result is easier access to challenging calcified canals. It is a heat tempered file. It has a twisted file designed for greater strength, and it easily penetrates calcified canals. Coming to the H file, H files are made by cutting and grinding the spiraling fluids into the shaft of a piece of round tapered stainless steel wire. The H file cuts in only one direction, that is retraction or the pull motion. H files, you can see the cross section here. It's a teardrop shaped cross section. Deep grinding of the surface of H file reduces central mass of metal, and thereby it should not be used in a rotational manner. It will break if we use it in a rotational manner. Modified H file was introduced by Mexpadden, and it was marketed by Unifile and Dynatrack. Basically, here we have a S-shaped cross section rather than the single helix teardrop cross section as compared to the Hedstrom file. So this S-shaped file helps in removal of necrotic debris as well. Now the S file is a variant of the Unifile in its double helix configuration. It's used with any hand motion, either filing motion or reaming motion, and can be classified as a hybrid design. Coming to micro debriders, H files characterized by short staff bent at an angle of 200 degrees with a long plastic handle is nothing but a micro debrider. So it's basically an H file only, and it clears away basically pulpal residue or GP and calcification. So they are micro debriders, and these instruments allow additional shaping of the canal. So when you need a final finish just before the obturation, you want a nice smooth finish in the canal, you can use a micro debrider. Coming to safety H files, basically any safety file has a non-cutting tip, and it prevents ledging and stripping in curved canals. So it resembles a wood screw, basically, as you can see in this picture. It has a non-cutting tip to prevent stripping. Coming to rotary instruments, these are the various motors which are used for rotary instruments, and they work on the principle of continuous rotation at a fixed slow speed. Now, what is a GG drill or a Gates Glidden drill? As you can see in this picture, it has a thin, long shaft and a flame-shaped head with a non-cutting safe tip to guard against perforation. It is made of hardened carbon steel. The flame-shaped head cuts laterally and is used with a gentle apical directed pressure. It has a modified safe tip, that is non-cutting tip. The instruments come in size 1 to 6. And this is a PEESO reamer. The PEESO reamer has long, sharp flues. You can see it's much longer and sharper as compared to the GG drill. It's used with a safe tip, and it is connected to a much thicker shaft. It is often used in preparing the coronal part of the root canal for a post and core. Now, this is the difference between GG drill and PEESO reamer. The size is same, 1 to 6, 1 to 6, but GG drill starts from 0.5 mm and PEESO reamer begins from 0.7 mm and increases by 0.2 mm consecutively till number 6. Night eye instruments are the latest advancement. I mean, latest compared, like let's say somewhere in the 1960s, 1970s, we started using night eye instruments. Now we have advances in night eye instruments as well, where we have something called as M-wire technology and P-wire technology. The exact what this technology is has not been explained. The companies have it as a trade secret, but they have again made a lot of advancements in night eye itself. The greatest innovation in endodontic instrumentation is the night eye instruments. Nitinol was discovered by Buehler and Wang in the early 1960s. The name nitinol was given because it comprised of nickel, titanium, and alloy. So they combined all the three and made it as nitinol, and nol because it was developed by the Naval Ordnance Laboratory. So we have superelasticity and shape memory, as I mentioned before. The alloy exists in two crystallographic forms, that is parent austenitic phase, which is stronger and stabler than the martensitic phase. So we have two phases. One is the austenite phase, which is the parent phase, and the martensite phase, which is the daughter phase. So usually on release of stress, the structure goes back to austenite. So we have a transformation from austenite phase to martensite phase and then back to austenite phase. So this is what leads to the superelasticity of the night eye alloy. Design of the night eye alloy, they are manufactured by grinding the file By grinding the wire to give a typical profile of a K file, the tip of the instrument is non-cutting, which is also known as bat tip. It makes the nitiplex file suited for curved canals without the risk of ledge formation. And niti files come in the size 15 to 60 with a taper of 0.02. Niti rotary endodontic instruments. This table here gives you an idea of all the files which are there in the market currently, and also those are not there anymore, like light speed instruments are not used anymore. It's a general idea of what the instrument system is, then what is the cross-sectional design, the tip design, and the taper of the particular file, and other features that enhance, that keep it separate from other files, that make it special. So we have a profile where you have a triple U shape, as you can see here, with radial lance, neutral rake angle, and it planes the dentine walls. It has a fixed taper of 2%, 4%, and 6%, and 20-degree helix angle with constant pitch. We have GT files with triple U shape and radial lance, non-cutting tip design, the fixed taper of 4, 6, 8, 10, and 12%, and these files have short cutting portion. GT files stands for greater taper files. Light speed instruments are no longer used. However, it is important to learn about them. Triple U shape with radial lance, it has a non-cutting tip. Specific instrument sequence produces a tapered shape, and thin flexible non-cutting shaft and short cutting head. Coming to Pro Taper, so Pro Taper is still the most widely used instrument even as on today, because of its ease of availability and ease of understanding its use. It has a positive rake angle, convex triangular shape, sharp cutting edges, no radial lance. F4, F3, F3, F4, F5 files have U floats for increased flexibility. So we have the shaping files which have partially active tips, and finishing files have non-cutting tip. So variable taper along the length for each instrument is present. Pitch and helix angle balanced to prevent instruments screwing into the canal. Similarly, we have Hero 642 and K3. Please go through the shape and the tip, the taper, as well as the special feature of each file, as you can see in the pictures here. Among these files, RACE is still very commonly used, and Quantec SC as well. RACE file is very effective for canal preparation. It has a triangular shape, 2% taper and 22% taper, two alternative cutting edges, and no radial land. It has a non-cutting tip and a fixed taper of 2%, 4%, 6%, 8%, and 10%. RACE was given the name because it has alternating cutting edges. So alternative cutting edges stands for RACE along the file length due to alternating twisted and untwisted segments, and a continuous wave design is present, which is intended to reduce the screw-in effect. M2 files again are extremely aggressive cutting files. They have an S-shaped design with two cutting edges, no radial lance, minimum core width to improve flexibility, non-cutting tip, fixed taper of 4%, 5%, 6%, and 7%, and a variable pitch, steep helical angle design to reduce screw-in effect. Coming to the twisted file, it has a triangular shape and no radial land, non-cutting. This file is not made by grinding and twisting. It is made by twisting the file as a whole. So only one single unit is twisted repeatedly in order to increase the strength of the file. It has a variable pitch. It is made by twisting a ground blank in combination with heat treatment, aims to increase superelasticity and cyclic fatigue resistance. In Pro Taper next, you have an off-centered rectangular cross-section, and there's no radial land and sharp cutting edges. So basically it's a non-cutting tip. And we have M-wire technology used here, as I mentioned before, but this M-wire technology, exactly what it is, has not been mentioned in any theoretical aspect in any article. It's just mentioned as M-wire technology. Coming to the clinical considerations. So do's, what are the do's that we have to do? Assess the canal anatomy thoroughly, achieve straight line access prior to instrumentation, follow crown down sequence, Use glide path for patency of canal. Use files for 5 to 10 seconds only. Adequate irrigation and lubrication between two files. Wipe flutes after each use. Examine files before, during, and after use. Don'ts. Instrument blindly. Never ever put the file inside the canal without seeing what you're doing. Stay in the canals for long. Never. Use of same files repeatedly. Files tend to wear and tear. Please do not use the same files repeatedly. Do not force the file inside the canal. Do not rotate for too long. Do not use a dry file. The canal must always be wet at any given point of time before you introduce the instrument. Don't use an unclean file. Please clean the file before use, and use file without inspection. Please check the file once it comes out of the canal for any kind of unwinding or wear and tear, and discard the file immediately. Coming to the conclusion, from a biological perspective, root canal treatment is directed towards the elimination of microorganisms from the root canal system and the prevention of reinfection. So now the technological advances that we have in the form of rotary NITA instruments have led to dramatic improvements in the ability to shape the root canals with potentially fewer complications. All right, thank you. These are my references. Please follow standard textbooks only as far as possible. It's also good to go through the latest literature that is available on in this topic as well as other topics in endodontics. I hope you enjoyed this session. Thank you very much.